Eighth grade math lesson 2.3 is kind of just the reverse of lesson 2.2. This is scientific notation with negative powers of 10. This would be useful for numbers that are very, very small. Like if you were studying the diameter of a little bitty atom and you were looking through a microscope and measuring things like that, or the diameter of a piece of hair, something tiny, tiny. So let's look at an example of a small, tiny, tiny, tiny amount in scientific notation. So this would be 25 millionths, tiny, like super tiny, something very, very, very small. And so if I wanted to turn this into scientific notation, again, I would want to move the decimal over until the point where the front number is going to be a number between 1 and 9. Not bigger, not smaller, just between 1 and 9. So right here, so that it's right behind this 2. Okay? So I'm moving it over like that. That required me to move it 1, 2, 3, 4, 5 spots in the opposite direction than I was before. I'm moving it to make it seem bigger. So I went in that opposite direction. So the scientific notation of that tiny, tiny, tiny number is 2.5 times 10 to the negative 5. And so whoever created the number into scientific notation is just telling us, hey, by the way, psst, I moved that decimal 5 spots over because that number is so tiny. We know it's tiny because of that negative exponent there. If I needed to move it back, I would just know, well, they moved it over this many times to make it so that it wasn't looking as tiny. They moved it over. So I just have to move it back 5 spaces to get it back to the standardized form of that number. Okay, hey, did you know the average size of an atom is 300 millionths centimeters across? So tiny. So I can't even imagine how tiny, tiny, tiny we're talking about. That would need to be an amazing magnifying glass or whatever. So we have the average size of an atom. We really, if we had to calculate stuff having to do with that, we really don't want to be dealing with all this 0.000 stuff. What a mess. So let's move the decimal all the way over to this side of the 3 so that our front number ends up being a single digit number between the numbers of 1 and 9. So 3 falls in there all the way to there. And we're going to call it 3.0 or just 3. We can just call it 3 because 3.0 is 3. So we're going to call it 3 times, and it's going to be the how many times we moved it in that direction to make it seem not so small. So we're going to move it 1, 2, 3, 4, 5, 6, 7, 8 spots. So to the negative 8. So 3 times 10 to the negative 8 power is this number in scientific notation. Same number, written differently, and we get used to it. What if they gave it to me in scientific notation and they want me to write it in standard form? Well, again, here they are telling us that they had this 2.33, well, they had something smaller than that, and they moved, this is telling us, hey, I moved that decimal way over this way because it was so small and I needed not to have that all those zeros between the decimal. So I'm going to take this. Okay, actually, I'm going to give some room because I just realized I'm going to need room on this one, on the other side. Because if they moved it over from here this way 6 spots, if I'm going to undo what they did, I need to move it 6 spots back. So here I go. 1, I need to create another spot. 2, I need to create another spot. 3, 4, 5, 6. There it is. So that number in standard form is 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5, 2, 3, 3. This is that number. That decimal is now moved. One common mistake I see is they'll leave the decimal here, and now you have two decimals in a number. Our numbers don't have two decimals in it, so be careful of that. Happens a lot. Even I make that mistake sometimes. So here is the number in standard form for this number in scientific notation form. And the best thing to keep in mind about the two differences between the positive exponent on scientific notation and the negative one is just keep in mind, if you are given a scientific notation with a negative exponent, if you were to rewrite that in standard form and you're wondering, which way do I move my decimal? Remember, if it's a negative exponent, we're talking about a very small number. And $2, we're not talking about $2 small. We're talking about like no such coin that tiny. So that decimal is going to need to slide way that way. Okay, if we're talking about a positive exponent, we are talking about a number so large that it was too many zeros to handle. I wish my bank account had that, but it doesn't. So we would be moving the decimal to the larger direction to make that number become larger and larger and larger, because they're representing it by the movement of the decimal. So that should help you. If you are adjusting it and you know it's supposed to be a small number, then that decimal goes in a small direction where it makes the number get smaller and smaller. If it's a large number, a positive exponent, you're moving that decimal in such a way that that number is getting larger and larger.